Hello, everyone. We'll get to the point of my name in a second. So I wanted to start by acknowledging the traditional owners of the land and sea country where we work and where a lot of the eco-RAP and RAP data is collected from, and recognize the elders past, present, and emerging. And I wanted to make a reflection after hearing Bob talk this morning. It came to my mind that we've been thinking and recognizing the traditional owners as the original scientists of the land and sea countries where we are. And in the case of the Great Barrier Reef, even though corals have been around Australia for about 500 million years, the current Great Barrier Reef, the one that is World Heritage, has only been there for 10,000 years after the last glacier age, which basically means the traditional owners of Australia have actually been the custodians of this ecosystem from its birth, for the whole time it has existed. And I wonder if there is any other example of an existing culture that has actually looked after an ecosystem that exists now and that they have looked after it from the time it was born. So I think that's really interesting. Now, going to the name, I'm not Adriana. We come from the same country, if that helps. But we have been collaborating in this space. My name is Juan Ortiz. I work at Ames. I come from Venezuela. I started snorkeling and diving in Venezuela when I was about 12 years old in some shore reefs or a beautiful national park that is there. And I remember clearly how in the back reef on some of those little cays, there were all these crocodile branches, some dead, some alive, and so many lobsters in between the branches. I remember snorkeling and thinking, this looks like a supermarket. You just dug down and you cannot see which one is the biggest of the lobsters because they all come out and show the antenna and all that. And then I went to uni to study ecology. I had not decided to do marine biology yet. And I started learning that the Caribbean reefs were quite degraded. A lot of that information from the Central and North Caribbean, and I kept going to the reef, and I was like, this is weird. I don't see this. I mean, reef still looks great here. And sure enough, a few years into uni, I went back to that beautiful place, and it pretty much was no longer there. And it hit. And then I went to the Northern Caribbean and said, well, this has been happening for quite a while. That's when I decided to do coral reef ecology as opposed to ecology in general. And then I came here to Australia, and I feel a bit like now we are in the same scenario. The Great Barrier Reef, as Katerina was saying, still has great recovery. We have great recruitment, but we have a big threat. And if we don't do something in time, we may repeat the experience some of us had already from the Caribbean. So let's hope we can help a bit and avoid that from happening. So I'm going to be presenting the work that we've been doing in relation to ecological heuristics to decide on site selection for survivorship and growth of deployed corals. And it's a work that has been led by Adriana, who's also from Venezuela and is in Palau at the moment spawning corals. I spoke to her last night. One of the species behaving really well, the other one not so much. And the internet connection wasn't good enough for her to be presenting remotely. The title of the talk that is in the abstract is the one in little font that you probably can't read. I made the bigger one just to be a little bit more entertaining because it's all about trying to avoid the little corals that we love so much and look after and try to make special from dying as soon as we put them out in the reef. So which one is the one that? Not that one? No. This one. Yeah. So the challenge, right? We are trying to influence reef resilience in a scale that has never been attempted before quite yet. We are trying to produce millions and millions of baby corals through different processes, whether it's bring them from some places or growing them in different places, but numbers that are quite huge. We are trying to find ways to make those corals a bit more tolerant by harnessing the information we have about their thermal variability through either symbionts or the genetics of the host, et cetera, already a big challenge. And then we have been thinking a lot about finding the right place to put them. So because we have to upscale, we need to get enough of it moving around. The spread of them is enhanced by connectivity, and we can be really smart and find the perfect place where we will get the most bang for our money. However, there is one critical point. It doesn't matter how well we can identify the perfect site for them to spread. If the quotas we put there don't grow, survive, and get to be reproductive, we won't get it, even if it was the perfect site for a spread, right? And in that sense, we know from the literature and the knowledge in ecology that small quotas are challenged. It's a bit like the National Geographic documentaries of Africa. It's a struggle for quite a few months and years for them when they get out. They have very low survivorship when they are little, and there are many reasons why they may not do so well. We also know that we can't really protect them that much. It's millions that we want to put out. We can't have a mom looking after them, each of them scaring everything away and making sure that everything is perfect for them. That's never going to happen. So that means that we have to find ways to use what we know to identify places where they have the best chance of growing, surviving, and becoming reproductive. And in that sense, we have started working. Those letters are really small in that screen from here. So we have started working on these rules and using the available information to start to develop a criteria under which you can rank sites based on their biotic and abiotic characteristics to try and maximize reef, the survivorship and growth of these quotas that we are deploying. So ultimately, what we are developing here is a set of rules that allow you to rank a set of sites you are considering for deployment as a function of how likely it will be that the quotas that you put there may grow, survive, and reproduce. And in that sense, we have developed a framework that is now already being discussed and used within our RAP that consider 3 different criteria. The first one has to do with the difference in environmental conditions between the place where the corals, the source corals are from, and the receiving sites where you are planning to put them. And we know that, as Katharina was saying before, the Great Barrier Reef and reefs in general are very complex, and there are very different environmental conditions in different parts of the reefs, especially, and also within a reef. And we also know that it's quite likely that if you bring corals to an area where the environmental conditions are fundamentally different to the ones where they come from, there may be challenges for them to thrive in that environment. So the first part of the criteria has to do with how similar or different those two source and receiving sites are. Then the second 2 parts of the criteria have to do specifically with the receiving site, and the first part had to do with the abiotic characteristics in that receiving site, and the second part it has to do with the biotic characteristics in that receiving site. And then this set of criteria are standardized and put into a format that allows to provide indices for each of these 3 aspects, and then overall indices for the combination of that when you want to rank all of the sites. So the principles here is that we use a combination of available information, new data, and mechanistic understanding of, current mechanistic understanding of the ecology and biology of reefs to come up with these criteria, which are still a work in process and will continue to be a work in process even after it's published, because we always get more information and better information. The idea is that the criteria can be evaluated through different approaches depending on the scale you are looking at. So if we start a bit with the first, the difference in environmental conditions between the donor site or reef and the receiving reef. And in that we have a set of criteria that compare whether the species that you are bringing already exist in the existing environment, whether the temperature regime is comparable between the two, whether the other environmental conditions that are well known are fundamentally different between the two, and when possible, we have provided thresholds and quantitative approaches to standardize these differences and decide whether, that's 2 minutes left or 2, yeah, all right. So, so when possible, we have decided and found those thresholds to be able to get to those. Importantly, the principle here is that when you apply these criteria, any of them, you get an index that the higher the number, the better the site. But in some cases, you have a no deploy output, where it says just doesn't matter, don't consider it, don't put it anywhere, just don't deploy there. When we then go to the abiotic characteristics of the site, we consider what we know about what little baby corals or small corals need to be able to survive. And we consider the slope, the rugosity, the keep you factor, which is still debated whether we'll keep in there or not, has to do with structural complexity, the wave exposure, and we use the available information we have to create a standardization that allows you to then get the values on the index and compare the sites. Now, these two aspects that we just described, the first two, most of it can actually be evaluated via desktop exercises because there exist spatial layers and spatial maps that are available that allow you to explore almost any site around the Great Barrier Reef with some limitations without having to go to the site. And this is important for what I'll say in a minute, in the pretty much last minute. So finally, in the biotic components, this includes how much coral is already there, how many coral, what is the density of corallivores in there, what are the conditions in terms of biological interactions that may prevent or maximize the survivorship or growth of these corals. Importantly, though, this part of the criteria we can't really evaluate from desktop exercises because first, the information is not available, but second, is dynamic. So even if we had spatial layers, they wouldn't be constants over time. So for this part of the final part of the evaluation, you need to go to the site and evaluate the criteria that is presented there. And that, over time, that could be done with traditional measures, and over time, more autonomous approaches may be developed that allow us to do that. However, there is only going to be a challenge because you can only go to so many sites. And there may be, in many situations, many more sites that are considered than the ones you can visit before deployment. So in that sense, we have developed the approach in a hierarchical way where the first two criteria can be evaluated first and filtering of bad sites can be ruled out. And then a smaller number of sites are the ones that are evaluated for the site visits and the biological conditions, which makes it more logistically manageable. And even in the worst scenario where after the filtering, you still have more sites than what you can visit, you still would have a ranking, so you can start visiting them from the best out of the first two rankings all the way down, and basically stop when you run out of time and still get important information. So the approach has now been prepared as a paper, and it's been submitted for review internally in the internal process in RAP and AIMS, and it's going to be submitted out very soon. And it's been already used, evaluated, and improved through different subprograms in RAP, including CAD, modeling and decision support, and their 2025 deployment guidance system project. And I think that's the end.
Great. Is this coming through all right? I'll just echo questions from the audience up here so that we don't have to scramble out of our seats. Do we have any online questions? Nope. Any from the audience? Yes, over there.
Has anybody done any study on the survival in a difficult environment when deployed to the Legastes farmer fish territories? Because I know there's evidence that that's where they recruit better. Is there any evidence that, I mean, like, because they protect them from crown of thorns and parrotfish and everything else? That's what we're finding, is that if we have a problem site, if we locate them critically in a farmer fish territory, they do so much better.
So the question... The question is there any research in this area about intentionally targeting farmer fish territories for larval sediment as for any outplanting, as they've observed success in those areas due to the farmer fish removing crown of thorns starfish?
So I know there is some research in this space. We haven't considered or included in the criteria at the moment, which we can reevaluate because, as I said, this will continue to be growing. There are some challenges in that space because part of the approaches that are being considered is to be able to upscale the deployment in a site. And the issue with being so restricted to such a small area within the site will require really guided deployment that will limit the scale at which or numbers that you can provide. So even if we were to bring it into the criteria, which we eventually could, it would probably be for very specific scenarios where you are focusing in a particular reef where you really want to maximize for a reason, and then you may go down that path. But for the broad application of the upscaling, I think it would be very tricky to implement. But we haven't explored it, so this is just off the top of my head.
Yep, question from online. Are the criteria fully applicable globally?
I think that question will depend on the person you ask. We thought of them and decided them with the hope that they would. And also the actual package, which is a dynamic Excel spreadsheet, provides a lot of functionality in the sense that you can define the objective for which you are trying to apply the criteria. You also can change the weighting of the different criteria, which is something that may be quite relevant when applied in different parts of the world. And we did try to incorporate the main mechanisms that are general and apply everywhere, but it's still yet to be tested whether that's the case. So once it's released and people start playing and thinking about it, that's when we really know how well it works. I'm sure it won't work everywhere the same way, but hopefully it can work in a broad enough set of conditions.
All right, thank you very much, Juan. Welcome to the next speaker, Mariana.